Hi everyone. So welcome back to my YouTube channel and let's get started with the next question of the top 150 interview questions of LeetCode. So today we are up with the question majority element. It's the easy question on LeetCode and let's just go through the question. We are given an array nums of size n and we have to return the majority element in the array nums. So let's discuss the majority element definition in this question, which is given below. The majority element is the element that appears more than n by 2 times, where n is the size of the array. You may assume that the majority element always exists in the array. So the one important condition, I think this is something a little bit deviated, what we can say. So we should always assume that we will always have a majority element in the array. So I think we will always get an answer according to the question, right? So let's get started with the question and just go through the constraints once. Like all the integers, all the elements in the nums array are in the integer range, and the length of the array of nums is up to 10 raised to the power 4 on an average, we can say, whereas it said that 5 into 10 raised to power 4, we can assume that it is 10 raised to the power 4. So from all of these constraints, first thing, we are sure that we don't have to go in something like O of n square solution, right? Because for O of n square, what will happen is, as our constraint is already given as 10 raised to the power 4 and 10 raised to the power 9, so it will turn out to be 10 raised to power 13 if we'll try something like nested for loops for elements. So O of n square solution is directly rejected as per the constraints. So something like we have to cut down to O of n. That's it. Okay, so let's write down the array. So let me draw my array first. I have an array nums. Let me take one example. 1 2 3 5 4 and then 1 1 1. Okay. How many elements are there? 5, and then 6 7 8, and then 4, and then let's take 2 more ones, right? So we have to set a test case according to what is given in the question, right? So we have 1 2 3 4 5 6 7 8 9 10 elements in our array. So what is the definition of majority is that we must have greater than n by 2 elements. It means greater than 10 by 2, which means greater than 5 elements, which will constitute the majority, right? So the frequency of the element which is majority in this array should be greater than 5. So that's what we are clear with it, right? So for a simple solution, as we can see in this array, what we can do, we can simply take an unordered map in C++ or hash map in Java, and we can store key value pairs where key will be the nums of I, and value of that key is frequency of nums of I. Frequency of nums of I, right? So we can take this thing, right? So I think if we talk about a pretty simple solution about this question is, we can simply take a hash map or a unordered map in C++ and simply store the count of elements that are there in this array. So one more thing, it comes to everyone's mind, we can also take a frequency vector, as most of you have already done a lot of questions, and even you have seen a lot of solutions on internet as well of taking a frequency vector. Generally this type of code you have seen where we have we have 26 alphabets, right? But in this case we are not taking this thing, right? Why? Because our numbers are in the range, are in because our numbers comprise of a whole of the integer range, right? So we can't take an array this much, so we can't take some frequency array like this which is big enough, because in that case we'll be occupying a lot of space. So that's why we have cut down our space size to a hash map. So let's just try to copy our solution in the hash map. So as given in the array, 1 2 3 4, and what I have is 5. 1 2 3 4 5, and 1 is having frequency 1 2 3 4 5 6. 6 is the frequency of 1, 2 frequency 1 1 1. And then what we will do, we will simply iterate on our map and check. Yeah, so checking the frequency of 1, is it greater than 5? Yes, it's greater than 5, so 1 is our answer, right? So I think this is a pretty simple solution. And let's discuss the time complexity of this solution. So what would be the time complexity? As we are traversing in whole of our array, right? So we are going on 1, we are going on 2 3 4 5 1 1 1 1. So we are moving over each and every element in our array, right? So what would be the time complexity of this solution? It would be O of n, and space complexity would be O of n. As in worst case, we can think about an unordered map, as we all, like, suppose you are having an array in which there are all the unique values, and you are storing the frequency of all those values in a hash map. So our space complexity can at max go till O of n. See, there is no point in discussing about we have unique elements, because in our question we don't have anything like this. But yeah, because in time and space complexity, why we take a big O notation is that we have to count the worst case scenario, right? So that's why we take big of n for space complexity, right? So space complexity, time complexity is O of n, and space complexity is big O of n. So I think this is a pretty simple solution. We all can code, and our interview is done. So it's really good that we have passed the interview. But then comes a climax in your interview. He asks a follow-up question related to this. So let's move on to the follow-up question of the same. So what's the follow-up? Could you solve this problem in linear time in O of 1 space? So I think in linear time we have already solved the problem, but the challenge comes with O of 1 space, right? So let's just move to O of 1 space solution. So for that, we'll be discussing a new algorithm, which is Moore's voting algorithm, or commonly a Boyer-Moore voting algorithm, BMV. Boyer-Moore voting algorithm. So most of you would be thinking that how this algorithm came up, whether we have to really remember this algorithm or not. And suppose if you are in an interview, you may forget to watch this algorithm, or you don't have any idea about this algorithm, or maybe you have watched and you have forgot about this algorithm, and because you have solved this question a long time ago, and you only remember some trace of this algorithm in the interview. So guys, don't mind it. Whenever you will be in interview, the DSA rounds are somewhat like discussion type, so interviewer will be constantly interacting with you in that case. Most of the times it happens, but sometimes I don't guarantee it. It all depends upon the mood of the interviewer, right? Because in some companies I have heard from my friends that whenever they ask the DSA question, they don't involve too much in this discussion, right? But if we talk about the fan companies like Microsoft, Facebook, Apple, Amazon, Netflix, Google, the interviews there are more or less interested to know about your problem solving skills. So there is a good discussion in those interviews around the DSA problems, right? So let's discuss the Moore's voting algorithm right now. So don't worry, even if you don't remember, then that's fine. But yeah, in this video we will discuss Moore's voting algorithm in detail, and also I will try my best so that it gets imprinted in your mind. But please don't worry about it. Even if you forget about it after some time, I will paste the link from where I have studied this algorithm in the description of this video. So right, don't worry, and you can save those links in your bookmarks. So let's move on to Moore voting algorithm. So what does Moore voting algorithm states? It is one of the optimal algorithms which is used to find majority elements among the given elements that have more than n by 2 occurrences. So this algorithm has already stated itself that it is used to find the majority elements amongst the given elements which have more than n by 2 occurrences. So this article is basically limited to n by 2, but I will provide a description of n by k occurrences, right? So you can go through both of them. So basically in this algorithm it takes two traversals over the given elements, which works in O of n time complexity and O of one space complexity. So I think we have got the answer to a follow-up question, that if we have to solve this question in O of n time and O of one space, we can use Moore's voting algorithm, right? So let's look at the algorithm and intuition behind it by taking an example. So talking about this input, 4 times 1, 2, 3, 5. 1 is the majority element amongst this because frequency of 1 is greater than n by 2, which is 7 by 2 greater than 3. So 1 is occurring 4 times in this array. So taking the next input 1, 2, 3, so output is -1 because there is no element in this array which is having a frequency greater than n by 2. So we can see that there are all unique elements, that's why output is -1. So this algorithm works on the fact that if an element occurs more than n by 2 times, it means that the remaining elements other than this would definitely be less than n by 2. So what is the intuition? So suppose we are in this array, 2, 3, 1 and 3, and then again 1. So what is the element which is in majority? It is 1, 1, 1 and 1, right? So what is the count of 1? It is 7 greater than 7 by 2, right? It means count of 1 is greater than 3. So what about the count of other elements in this array? 2, 3 and then 3. It is 3. So it is not greater than 3. So it means that always your majority elements have a greater count in your array, and the elements which are not in majority will always be less than n by 2. I think this is super common sense, but still let it to be clarified, right? So in this algorithm, first we choose a candidate from a given set of elements, and if it is same as the candidate, we will increase the votes, otherwise we will decrease the vote. If vote becomes 0, select new element as new candidate. Okay, so let's get to some of the algorithm part. So let me take one element as one variable as candidate. Let it be -1, and let me take a variable as vote, and let it be 0, right? So we are taken vote as 0. Now let's iterate through this array. So let's iterate through this array for I and nums. So if my vote is 0, what I will do, I'll simply set my candidate to I and increment my vote, right? And suppose there are two cases. So what will happen in this case? So talking about 1. So at this point our vote is 0. We will simply assume that our candidate is 1. So the value of our candidate over here is, so candidate is 1 and our count of vote is also equal to 1. So iterating to next element, which is 1. So let's take the next condition, else if our I is equal to candidate, what we will do, we will simply increment our vote, and else if, so 1 is equal to the candidate, so I'll increase my vote to 2, right? So talking about 2, what is 2? 2 is not equal to 1, right? So what we will do, we'll simply decrement our vote, okay, right? So now the value of vote over here will be 1. We have decremented our vote. So talking about 3 is not equal to candidate, we'll decrement our vote and our vote will become 0, right? So moving to 1 is equal to our candidate, so moving to 1, at this point our vote is equal to 0. So what we will simply do, we will simply set our candidate to I, which is 1. So we'll simply set our candidate to 1 and increment our vote to 1, right? So moving to 3, so 3 is not equal to 1, we will simply decrement our vote and our vote will become 0. So at this point our vote has become 0. So if vote is equal to 0, we will simply set our candidate to 1 and increment my vote, and at last whatever is remaining, whatever is the value of that candidate, we will simply return that, and that will be our answer, right? I think the working of this algorithm is pretty clear. But now let's discuss why we have done this thing. So what is the intuition behind doing this? So what's the intuition behind doing this? We all know that our majority elements count will always be greater than n by 2, and the elements which are not in majority will always be less than n by 2, right? So what we are doing in this scenario, we are basically cancelling out the priority of winning of an element over the majority element. How? I think this is a little bit confusing, but what we are doing, we are basically cancelling out the, cancelling out the priority of non-winning elements. I'm sorry, I just slipped my tongue. So we are just cancelling out the priority of non-winning elements, right? What we are doing, whenever we took our candidate as 1, we'll simply increase our vote. Whenever we have got our candidate, we'll simply increase, and when we have not got our candidate, we'll simply decrease our vote. When we have not got, we'll simply decrease. So what we are doing, we are cancelling out their occurrences. So in this subarray, what is happening, we are cancelling out the occurrences of 1 and 1 with 2 and 3, right? It has got a little bit dirty. So what we are doing in this subarray, we are simply cancelling the priority of winning of 1 with 2 and 3. So in this subarray of size 4, we don't have any priority element at all. So so there is no priority. It means there is no element which has frequency greater than n by 2. So that's why we took two variables, element, vote and candidate, right? Because here we have increased, here we have increased, here we have decreased, here we have decreased. Because what we are doing in this process, we are basically cancelling out the priority. We are basically cancelling out the winning chances of an element, right? So in this array, so in this part of subarray, which is of length 4, which contains 1, 1, 2, 3, there is no element in priority, right? So at this point, our vote has already become 0, right? So moving further in this part of the subarray, which is till the end. So let's move over here. So because our vote is 0, so we will simply check. Since our vote is 0, we will simply assign our candidate to 1 and we'll increment our vote. And then what happens is 3 is not equal to 1, 3 is not equal to candidate. So we'll simply decrement our vote. And what has happened in this part of subarray when our vote has become 0 again? So in this part of subarray also, we have not got anything which is in priority. So we have cancelled out the chances of winning. So here let's see. So 1, it has occurred once, we have increased our vote. 3, it has occurred once, we have decreased our vote. Because 3 is not equal to the element which we have assumed to be our candidate, which is our answer. So 1 and 3, they both cancel out each other. So winning priority, so the priority element does not exist in this subarray, right? So we will move further. So talking about 1, because whenever our vote will get equal to 0, it means in that part of subarray we have not got a priority element, right? So moving further, talking about this 1. So let's assume that our candidate is 1 and now we will increment our vote to 1. And since we have reached the end of the subarray, so whatever would be the value of our candidate, we will simply return. See, so what we are doing, we have basically divided our approach. So we can simply say that we are basically doing something like divide and conquer, but it's not really divide and conquer. We are basically cancelling out the winning chances of elements in our array, right? Because in the part of the subarray where our vote will automatically get reduced to 0. See, in this part our vote has got reduced to 0 at this point. In this part our vote has got reduced to 0. So it means whenever our vote is getting reduced to 0, it means in that portion of array there is no priority element, right? So we can simply move further and we can simply assume our candidate to be the next one which is coming up, which is the upcoming. So that's why I can simply assume that 1 is a candidate, right? I think it might have gone fast, but yeah, let's discuss it again. So let me just repeat whole of this thing. So in this question we know our priority should always be greater than n by 2, right? So it means the remaining elements which are there in the array should always be less than n by 2, right? So let me just copy this array once. Let me take some other example, right, which is much better. Let me set some sorry, 1 2 3 1 2 3 and 1 2. Okay, so let's get started with this. we know our candidate, we'll assume our candidate to be 1 at first go, and our vote is also 1. Okay, so what we are doing at this point, we have assumed that our candidate is 1, which is a majority element, and we will increment our vote. So moving further in this array, so 2 is not equal to 1, we will simply decrease our vote. So what has happened in this portion of subarray? We have basically cancelled out the priorities, winning priority like 1. So it means that in this portion of subarray, we don't have our answer, because our vote has reduced to 0. It means there is no element in this portion of the subarray which can be our priority element, because there is no value in this subarray which is greater than n by 2. N by 2 over here means the length of this subarray, which is 2, greater than 2 by 2. It means greater than 1. So there is no element like this. So we can safely move further. So 3, because our vote has got reduced to 0, so we can simply update our candidate element to 3 and our vote to 1, right? Okay, and then moving to 1, since 1 is not equal to 3, we will simply reduce our vote to 0. Okay, so what we have seen in this portion also, what we have seen, so we have seen that there is no element in this array, in this portion of subarray, which is greater than n by 2, which is greater than 2 by 2, greater than 1. So it means there is no element which can form the majority, right? Which is not satisfying our condition of majority. Okay, so let's move further. Let's move to 2. So vote has already become equal to 0. We will simply cancel it out. So we will simply update and increment our vote to 1. Okay, so 3 is not equal to 2, we'll simply decrement our vote to 0. So whenever our vote gets reduced to 0, it means in that part we have not found our majority, right? So in this case also, in this subarray which comprises of 2 and 3, no element greater than 1, no element is greater than 1, so there is no element which can form majority, right? So we will simply cancel this. So it means till this point, till the 6th element in this array, we don't have any element which is actually our majority element, right? So we can move further. So it means there is no element which actually wins our condition of n by 2, right? So what we will do, we will simply, since our vote is already equal to 0, we will simply update our candidate and increment our vote. So 2 is not equal to 1, decrement our vote to 0. So what has happened in this portion? Again the same story, that there is no element which is greater than 1, right? So there is no element in this array which can actually form the majority, right? So what we can say, in this portion we have also got 0, in this portion we have also got 0, we have got 0, we have got 0 over here. So it means in the first 7 elements, in the first 8 elements, during the first 8 elements of our array, all the elements are existing equally likely. It means the number of ones are equal to the number of elements which are not ones. So it means there is no concept of majority amongst these 8 elements, right? So there is no element in this array which is greater than 9 by 2, which is greater than 4. So there is no elements which are greater than 4. It means all the elements have equal chances of winning. It means the number of ones in this portion are more or less equal to number of other elements that are there in the array, right? So I think this is good enough. Okay. So now comes the last element, which is 1. So our candidate is, so what we can simply assume? We can simply assume our candidate to be 1 and our vote to be 1. And at this point our array has already got eliminated. So we can simply return the answer that is present in the candidate, right? So I think we are done with this array. So I think you all might have noticed one error that I have made in this test case, which is that I took the elements in this array which is majority is greater than or equal to 4, right? So it means what we can say, that this test case, so this algorithm also passes all the test case where we can have an element greater than or equal to n by 2. Yeah, we can say, but only for some few test cases, right? But for the others it will not pass, right? So don't ever try this test case again. I think it's accidental. Okay, so now let's just move on to the code of this question, right? So let's move to the code part. Let me reset my code. So taking int n equal to nums dot size, taking a variable candidate equal to -1, let's say, but I will take something like 0 because I don't know what element we can have. And let's take our element to be so let's take our element to let's take our vote to be 0. Okay, candidate and vote we have already taken, so we will iterate through our array. I'll iterate using this loop, and then I'll check if my vote is equal to 0. I'll simply assume that my candidate is equal to I and my vote, I'll increment my vote. So I will check if my candidate is equal to I, then I'll simply increment my vote, or else if it's not, I'll decrement my vote, and then I will return at last the candidate. So it is run. So I think my solution has also got submitted. So thanks guys for watching this video. If you like the content which I've shared, or if you like the way I explain the question, please do like and subscribe my channel. So it would really help me a lot. And if you feel that if I've missed out something, or you think that I can add on something more, please do mention it in the comment section. And if you want to connect with me for more such queries, like how to prepare for the placements, or how to answer the questions in interview, or for some long-term mentorship, you can connect with me on the platforms mentioned in the description, which is LinkedIn, TopMate and Preplace. So thanks everyone for watching this video. So bye bye.